In this video, we're going to look at double angle formulas for sine, cosine, and tangent, and then we will look at half angle formulas for sine, cosine, and tangent. The first example I'm going to do of these two examples is that we are going to pick some place that's easily findable on the unit circle. The second example, after doing the half angle and double angle formulas for sine, cosine, and tangent, is going to be one that isn't so easily found. So the first thing we're going to do is use the process that we can do for every single problem. We are going to first of all figure out where are we on the circle, and that is going to be given to us by secant and cosecant. Now we're going to do a little bit of detective work here because the first thing we need to recognize is that the secant is positive. The secant is positive, and the secant, if we were looking at this, the secant is the reciprocal of cosine, and since cosine is x, this would be 1 over x. So when is x positive? Well, x is positive when we're either in the first quadrant or if we're in the fourth quadrant. Now, cosecant is negative. Here, the cosecant is less than 0, and since cosecant is less than 0, cosecant is the reciprocal of sine. And sine is y, so the cosecant is 1 over y. Well, when is y negative? Y is negative in quadrants 3 and quadrant 4. So if our positive secant is positive in first and fourth quadrant, and our cosecant, which is negative, in the third and fourth quadrant, then we must be in the fourth quadrant. This little detective work here will get you to drawing your right triangle. This is a right triangle with theta, so we can find this measurement right here, and we can do that because we are going to take the information we're given, which is secant, equals 2, and we can figure out 2 of our 3 sides. Now remember, our secant is 2, or we can write that as 2 over 1. Now, if we go back to our mnemonic device, SOHCAHTOA, we can think back to what does cosine represent in terms of its relationship to theta. Cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. Therefore, secant of theta is hypotenuse over adjacent in relative to theta. So since our secant is 2, this would be 2 over 1. So our hypotenuse is 1, and our hypotenuse is 2, and our adjacent side is 1. Now we have to find the missing side, this missing y distance right here on this right triangle. We can use the Pythagorean theorem, a squared plus b squared equals c squared, but I like going x squared plus y squared equals hypotenuse squared. So our x in this case is going to be 1. Our y is going to be the unknown, and our hypotenuse is going to be 2. So we have 1 plus y equals 4. So y is equal to 3, and the y is squared in each of these situations. Then we take the square root of y, and if we take the square root of y, what we have y is equal to plus or minus the square root of 3. We have to think about the plus or minus possibilities because of the location that we are in the fourth quadrant. And in this case, we would be a negative. And we're negative because the y value is negative in the fourth quadrant. So this is our correct triangle, 1, 2, and square root of 3. Now what we can do with this is we can use this information to help us get to the double angle formulas for sine, cosine, and tangent, and then the half angle formulas. Now let us do the sine of 2 theta is equal to 2 sine theta cosine theta. In a previous video, I went through some of the reasons why this is true, so if you're looking to derive these formulas, you can kind of check my previous videos. So what we have here is looking at just plugging in, based on this triangle here, the sine theta and cosine theta, and this will give us our double angle formula. Alright, so if we just multiply 2 times the sine of theta, sine according to SOHCAHTOA is opposite over hypotenuse. This is negative square roots of 3 over 2. And then what we have is cosine, which is adjacent over hypotenuse according to SOHCAHTOA, and this is going to be 1/2. So if we multiply top times top times top, That's 2 times negative 3 times 1. But there's some simplification I can do before I just even multiply top times top times top. I can actually do some quick simplification, and you may call this cancellation. But the quick simplification is that if a numerator has a 2 and the denominator has a 2, those can both divide by themselves to make 1. So now I have 1 times negative 3 times 1, which is negative square roots of 3, and 1 times 2, so negative square roots of 3 over 2 is my answer for the sine of 2 theta. It might be good to write this down because I'm going to kind of recall back to this when I get to the end, because I'd like to show you how maybe you can check your answers. So now that I have this, let's do the cosine of 2 theta. The cosine of 2 theta is going to be the formula cosine squared theta minus sine squared theta. Okay, so now what we get to do is plug in our cosine for this and then square it. And in this case, the cosine was 1/2, and we'll be squaring that, and then we'll be subtracting sine. We'll square that, which is negative square root of 3 over 2. And then subtract that. So if I square 1/2, 1 times 1 is 1, and 2 times 2 is 4. The negative square root of 3 times negative square root of 3 is positive square root of 9, or just 3. And 2 times 2 is 4. Be careful when you look at these two negatives here. Sometimes people take these two negatives and make them positive, but you have to follow order of operations correctly. So 1/4 minus 3/4 is going to be negative 2/4, which is reducible to negative 1/2. I would strongly recommend that you write down this answer too, because what we will be doing is checking our answer at the end of this problem. And you might find, as we get to the end, you'll be like, oh, really? That's quite obvious. But let's go to the tangent, the double angle formula, tangent 2 theta. For the double angle formula for tangent, we have tangent of 2 theta is equal to 2 tangent theta divided by 1 minus tangent squared theta. So we plug in our tangent, which is our opposite over adjacent. So this is 2 times negative square roots of 3 divided by 1. In our denominator, we're going to have 1 minus our negative square roots of 3, that's our opposite side in relation to theta, divided by 1 quantity squared. All right, let's do some simplification. In this numerator, what we have is 2 times negative square root of 3, so negative 2 square roots of 3. We don't have to write the denominator of 1. Now down here in the denominator, we have 1 minus negative square root of 3 squared. What is negative square root of 3 squared? Well, that would be a positive square root of 9, which is the same thing as 1 minus 3. What we then have is we have a very simple denominator to simplify. So my numerator is negative 2 square roots of 3, and my denominator is negative 2. And then since these are the same, negative 2 divided by negative 2 is just 1, or just square root of 3. Now I'd like you to write down this answer. The tangent of 2 theta is equal to the square root of 3. I think you're going to find this kind of an amazing answer when you go check it at the end. So the next part we're going to do is move on to the half-angle formulas. For our half-angle formula for sine, the half-angle formula for sine is plus or minus the square root of 1 minus cosine theta over 2. Now I would like to address the plus or minus at the very end of the problem. I would like to now start by plugging in what we know for cosine. Well, we know for cosine, according to SOHCAHTOA, cosine is adjacent over hypotenuse. And since adjacent over hypotenuse is 1/2, this makes the problem pretty nice to deal with, because what we have inside the radical is 1 minus 1/2, and then we have a 2 in the denominator. So 1 minus 1/2 in the numerator is going to be negative 1/2, or sorry, positive 1/2. And dividing by 2 is just like multiplying by positive 1/2. So again, I've kind of combined two steps. 1 minus 1/2 is 1/2, and dividing by 2 is multiplying by the reciprocal of 1/2. So now what we have is plus or minus the square root of 1/4, which is the same thing as plus or minus the square root of 1 over the square root of 4. Now we can simplify that even further by saying that the square root of 1 is 1 and the square root of 4 is 2. Now the question is whether this is a plus or a minus. We're going to decide based on the fact that we are taking something in the fourth quadrant and cutting it in half. Now, the fourth quadrant goes from 270 degrees to 360 degrees. Now, if I cut each of those in half, that would put me in the second quadrant, because 360 degrees cut in half is 180, and 270 degrees cut in half is 135. So, if I am in the fourth quadrant and I cut that angle in half, then I am going to be in this part of the second quadrant. And since this is sine is a y value, and therefore this is a positive answer. So the answer to this problem, or the half angle formula for sine of theta divided by 2 is 1/2. Now for cosine theta, which cosine theta divided by 2, it's the exact same formula except with a plus instead of a minus for cosine. Now we could work through this entire problem again, but really what changes is just the minus versus the plus. Now that means that I can kind of go to this step and say, okay, so how would this problem be different if I plugged in 1 plus 1/2 divided by 2? Well, I'm going to kind of borrow from this step over here and say that, well, instead of 1/2, that it's going to be 1 plus 1/2 or 3/2. Using your previous work is really going to save a lot of homework time for you. Multiplied by 1/2. So what this means, I have plus or minus the square root of 3/4, which is the same thing as plus or minus the square root of 3 divided by the square root of 4. Little radical properties there. So therefore, my numerator is going to be the square root of 3, and my denominator is going to be 2. But now I have to think again, like where am I going to be in this half angle formula? I took my theta and I divided it in 2, which puts me somewhere in this zone of the second quadrant. Now since cosine is an x value, the x values in the second quadrant are negative. So your answer to this problem is negative square root of 3 over 2. Okay, for the last part of this first example here, we are going to look at the half angle formula for tangent. Now there were 3 formulas that we could use. I tend to stay away from the one that has the plus and minus in it because that could get into some complications because we are working with a plus or minus and it's easy to make that mistake. So I like to look at one of these 2 formulas which also work for the half angle formula. This is 1 minus cosine over sine of theta, or we can look at sine of theta divided by 1 plus cosine theta. Now how I choose which formula to use is all based on which one gives me the easier denominator. If I use the first formula, the sine theta is going to be opposite over hypotenuse, which puts a square root in the denominator, so I'm not too excited about that. Whereas in the second formula, I'm noticing that my cosine is an adjacent over hypotenuse, which puts a 1/2 in the denominator, which is a lot easier than a radical. So I'm going to use this instead of this. So the sine theta is going to be the negative square root of 3 over 2. 1 plus cosine theta is going to be 1 plus r adjacent over hypotenuse, or 1 plus 1/2. So I'm going to just work on my denominator here of this complex fraction. 1 plus 1/2 is going to be 3/2, or 2/2 or plus 1/2 is 3/2. Then I have negative square root of 3 over 2 in my numerator. Now, if I want to divide these 2 fractions, I skip, flip, and multiply. So I'm going to skip the first fraction, negative square root of 3 over 2, flip the second fraction, and then multiply them together. This 2 and 2, they can divide because 2 divided by 2 makes 1. And so I have negative square root of 3 over 3. That is my answer for the cosine of 2 theta. So we're going to check our answers now. Now, what you might have to do is go back and look at all of the different answers here, and I'm going to write them down and come back in a second to show you what the checked answer looks like. So here we have all the answers of the problems that we looked at for the half angle and double angle formulas. Now, one of the things about this problem that makes it kind of easy to check is because the secant theta equals 2 when the cosecant is less than 0 is on the unit circle. We've drawn many unit circles, and you have unit circle charts probably flowing out your notes in many different places, or can easily find one on the internet. But what we need to show here is that this angle right here is negative 60 degrees. So this theta in the problem is equal to negative 60 degrees, which is equivalent to a positive rotation counterclockwise of 300 degrees. Now what I need you to do is check that answer out when you basically double all of these answers. So if you double theta, so you get the sine of 600 degrees, the cosine of 600 degrees, and the tangent of 600 degrees, we can do a little bit of math to figure out what the answer is for theta. We can easily take the angle theta, which is 300 degrees, and double it. And we got your 600 degrees, and we can come up with an equivalent value like this. The sine of 600 degrees, which is the same as the sine of 360 degrees, taken away from 600 degrees, so you can easily figure out the sine of 240 degrees based on your unit circle. And if you look at the 240 degree angle of your unit circle, you will then see that the sine value at that location is indeed negative square root of 3 over 2. And the cosine of 240 degrees is negative 1/2, and the tangent at that 240 degree mark is at square root of 3. You might have said to yourself, well gosh, if I would have just done that from the beginning upon recognizing what this theta is, I could have saved myself a lot of time and work. And the answer is yes. The next example we're going to do after this is going to be one that you can look up on a unit circle. So it's nice to be able to do some of these examples that have much quicker shortcuts than first experienced, and especially you can kind of check your work right now pretty quickly. And can you do the same thing for this too? Well, sure. If theta was 300 degrees, then the sine of theta divided by 2, this would mean that the sine of 150 degrees is 1/2. The cosine of 150 degrees is negative square root of 3 over 2. And the tangent at 150 degrees is negative square root of 3 over 3. These can all be verified based on your unit circle chart. So again, if you are doing a homework problem and you're finding that your values correspond to places on the unit circle, you can just double the angle or cut the angle in half and get your answers without doing all the complicated formulas. But you're going to see on your assessments, like your tests and maybe your final exam, you're going to see a spot where you're going to need to go and get things that aren't on unit circles, so you can't find those answers very easily. So in the second half of this video, we're going to take a look at a much more complicated problem because they won't be easily checked. But with the graphing calculator, you'll be able to take care of that very easily. For this final example in the video, we are going to do the half angle and double angle formulas based on this location in a circle where the cotangent theta is equal to 3 and the cosine theta is less than 0. Now, the first thing is that you'll note that if you are looking up anywhere on the unit circle, like any of the unit circle charts you've done, cotangent theta was never ever equal to 3. So what this means is that we are going to have to make a brand new right triangle to find all the relationships and maybe get the answer for this theta position. The cosine is negative, so this is going to help us in determining our right triangle. So let's think about cotangent. Cotangent is x over y, and cotangent is, instead of opposite over adjacent like tangent, it's adjacent over opposite in relationship to theta. Now we note that cotangent is positive, and cotangent and tangent are positive in quadrants 1 and 3. So we are going to now look at cosine. Cosine is an x value, and the x value is negative. Well, when is x negative? X is negative in the second quadrant and also the third quadrant, which means that if we are in the first and third quadrant based on cotangent and the second and third quadrant based on cosine, then we're in the third quadrant. So we're going to draw a third quadrant triangle to give us our nice reference angle from position theta, and now we're going to use our cotangent relationship, and we can take our cotangent, which is adjacent over, instead of opposite over adjacent for tangent, it's adjacent over opposite. Our cotangent is 3 over 1. So our 3 is going to be here, and our 1 is going to be here. Well, one of the more common mistakes when looking at cotangent, since cotangent is positive, these are negative distances from the origin. So this is a negative 3 and a negative 1 for our x and y value respectively. So you got to be careful when doing this problem that this is a negative 3 and this is a negative 1. So let's now actually find the missing hypotenuse. The hypotenuse is going to be the part of x squared plus y squared equals h squared. And our x squared plus y squared is going to be our negative 3 quantity squared plus negative 1 quantity squared equals our hypotenuse squared. So this is going to give us 9 plus 1, because negative 3 times negative 3 is positive 9, is equal to the hypotenuse squared. So 10 is equal to hypotenuse squared. So we take the square root of both sides, and we have the square root of 10 is equal to the hypotenuse. Now normally we'd have the plus and minus to contend with when we're dealing with x and y, but because this is the hypotenuse for the sake of our examples will always be positive. So this is going to be our square root of 10 for our triangle. So for our first double angle formula, we're going to do the sine of 2 theta. And the sine of 2 theta is 2 sine theta cosine theta. So we look back at the right triangle that we made here in the third quadrant, and we say, okay, what's my sine relationship? According to SOHCAHTOA, it's opposite over hypotenuse. And the cosine is adjacent over hypotenuse. So now we multiply top times top times top, which gives me an answer of positive 6. And bottom times bottom, which is the square root of 10 times the square root of 10, which is the square root of 100, or just 10. And we simplify this fraction and we get 3/5. Now, in the previous problem, we found that we could check our answer by looking on the unit circle and doubling the angle. Well, we actually can't do something that quick this time. So if the answer is not in the back of the book or in a solution manual, there's a way using a calculator we can find out if the sine of 2 theta is 3/5. Stay tuned to the end of this video for that check. So let's do cosine theta, or cosine of 2 theta now. So we're taking that angle in the third quadrant, or that angle all the way around, and we're going to double this angle. And so this formula is going to be cosine squared theta minus sine squared theta. Whoops. There we go. And now I'm going to plug in my cosine value and square it. The cosine value is the adjacent side over the hypotenuse. And then we're going to square that, and then subtract from that the sine, which is the opposite over hypotenuse, and squared. So let's do some manipulation. Simplification. Negative 3 squared is 9, and square root of 10 squared is 10. The negative 1 squared is 1, and the square root of 10 squared is 10. So 9/10 minus 1/10 is 8/10, which is reducible to 4/5. This is again something we can check at the end of the problem. So for our final double angle formula, the tangent of 2 theta, we're going to see what happens when we plug in our tangent for 2 tangent theta divided by 1 minus tangent squared theta. So what's great about this is that the tangent is actually just 2 integers, negative 1 and negative 3. According to SOHCAHTOA, tangent is opposite, so negative 1 over adjacent relative to theta. And we're going to have that there, and 1 minus this negative 1 over negative 3 quantity squared. So here I have 2 times negative 1 over negative 3, which is just 2/3. And in my denominator, I now have 1 minus 1 squared, which is 1. 1 minus 1 squared, which is 1, and then 3 squared, which is 9. So I've got a little simplification to do in my denominator of my complex fraction. So this is going to be 9/9 minus 1/9. So I got 2/3 over 8/9. And then I'm going to skip, flip, and multiply. When dividing fractions, you just skip the first fraction, flip the second fraction, and multiply. So this is 2/3 times 9/8. And we can do some simplification diagonally. This 9 divided by 3 is 3 over 1. And then 2 and 8 divide both by 2, so it becomes 1/4. So 1 times 3 is 3, and 1 times 4 is 4. So this is my answer for the tangent of 2 theta. Write this answer down because we're going to be checking our answer at the end of this video. Okay, so for the first of 3 half-angle formulas, we are going to look at the sine of theta divided by 2, which is the formula of plus or minus the square root of 1 minus cosine theta divided by 2. I like saving the plus or minus reconciliation until the very end of the problem. Some people take care of it at the beginning. I like to wait to the end. So let's plug in cosine. Now what's going to be kind of tricky here is that our cosines for this problem are going to involve a square root. So there's going to be a lot of radical rules of simplification here. And according to the math grammar, we can't just leave things in the denominator just because we'd like to. But I can tell you where there's a pretty acceptable stopping point. So if we plug in the cosine theta, the cosine is adjacent over hypotenuse. So we have 1 minus negative 3 over the square root of 10. And that's all divided by 2. Now that 2 is inside of the radical. You got to make sure that what I almost did is I almost left the 2 outside of the radical, but it's part of this, what's soon to be a very complex fraction. Now what I like to do is I like to reconcile this square root in the denominator of my numerator. So I'm going to multiply this top and bottom by the square root of 10. If I multiply the top and bottom by a 1, which is square root of 10 over 10, then I get to manipulate this a little bit easier. Because now in the numerator I have 1 minus, or plus in this case, because this was a minus negative, 1 plus 3 square roots of 10 divided by 10. Because the square root of 10 times square root of 10 is 100. Square root of 100, which is 10. And then this whole thing is divided by 2. Now what I can do is I can actually combine I can make this, instead of a 1, a 10 out of 10. And that's by multiplying the 1 by 10 over 10. So now I can have a nice fraction in my numerator, nice-ish I should say. So it's 10 plus 3 square root of 10 all divided by 10, and the whole thing is divided by 2. Now I can turn this this complex fraction into just one fraction by taking this division of 2 and changing that into multiplying by 1/2. So what this means, and I should bring along my plus minuses, I haven't dealt with those yet. I have 10 plus 3 square roots of 10 divided by 10 multiplied by, now 2 flipped over here on its head would be 1/2. And so this makes plus or minus the square root of 10 plus 3 square root of 10 divided by 20. Now, if you're looking to see when this matches in the back of the book, what you're going to find is you're going to find that they're going to have to simplify this just a little bit further, noticing that the 20 is breakable into 5 times 4. So this is what they do. They take the square root, and then they take this 20 in the denominator and make it 1/4 here, times 10 plus 3 square roots of 10 divided by 5. Notice the 4 times 5 makes 20, and the 1 times this binomial in the numerator is the binomial. What this means is I can then split this into, kind of bring this up here, plus or minus the square root of 1/4 times the square root of 10 plus 3 square root of 10 divided by 5. Okay, so the square root of 1/4 is the same thing as the square root of 1 over the square root of 4, and we showed you that earlier in the video. So this means I have a plus or minus 1/2 times the square root of 10 plus 3 square roots of 10 divided by 5. Now this is where the problem algebraically can end. The reason why is because we now have a square root inside of a square root, and this would become a cyclical pattern if we try to get rid of this square root by multiplying by 10 minus square root of 3 over 10 as a binomial. It's just, this is the place to end. This is a non-decimal approximation of the exact answer because nothing is rounded, and this is the answer as long as we finally land on whether this is plus or minus. Now the answer to that problem is that it's going to be plus, and let's explain why. If I'm in the third quadrant down here is anywhere between 180 degrees and 270 degrees. So if I cut any angle in half, I'm going to be in this portion of the second quadrant, because 180 divided by 2 is 90, and 270 divided by 2 is 135, which means that I'm going to be a sine in the second quadrant, and the sine in the second quadrant is positive. So my answer in this problem is going to be positive 1/2. Oops, didn't mean to jump the screen there a little bit. Let me bring that back. Positive 1/2 square root of 10 plus 3 square roots of 10 divided by 5. Now, you might think to yourself, oh my goodness, I am just going to be totally disappointed that I'm going to be doing the sine or the cosine of theta divided by 2. But by keeping everything here on the screen, I can show you that we can make this problem just a little bit easier because you're going to see that we're going to have a lot of the same things because the formula is just a plus instead of a minus. So over here to the side, I'm going to put cosine of theta divided by 2 is equal to plus or minus the square root of 1 plus cosine theta divided by 2. So where would this have made a difference in the problem? Well, in fact, the only difference it would have made is right over here in the problem where you had this minus and this other minus. But in this case, since we would be plugging in our negative 3 over square root of 10, the problem, instead of having a plus in the middle, would actually have a minus. So in fact, I can just take this answer and bring it over here as plus or minus 1/2, and the entire answer here, which is going to be the square root of 10 minus 3 square roots of 10 divided by 5. Now, we have to figure out what is our answer going to be there. Is it going to be a plus or is it going to be a minus? Well, again, remembering we are in this part of the second quadrant. We're in that, so what would cosine, which happens to be a x value, what is the x value in the second quadrant? Well, the x value in the second quadrant is always negative, so the answer to this problem is in fact negative. So if we take our little eraser, we can then erase everything but what we needed here, which was this minus 1/2 times the quantity of the square root of 10 minus 3 square roots of 10 divided by 5. So this green answer here at the end is my answer for the half angle formula for sine, and this answer over here is my answer for cosine theta divided by 2. Now, I would write down both of these answers because I want to show you how we can check our answer at the very end. So for our final half angle formula, we're going to look at the tangent of theta divided by 2. Now I have two choices. I've got 1 minus cosine theta over sine theta, or sine theta over 1 plus cosine theta. I'm not a big fan of the other formula because it has a square root in it, and it has a plus or minus option. So since you're bound to make fewer mistakes, you could choose one of these two options. Now, which one am I going to choose? Well, I'm first of all going to take a look at sine and cosine and see if one of those values doesn't have a radical in it. And unfortunately, both sine and cosine have the square root of 10 in it. So I'd rather use this formula because if I'm going to have a square root of 10, I do not want my square root of 10 in the denominator. So I'm going to basically say nuts to that. Now, I am going to plug in my formula, and you're going to see that things are going to get a little hairy and scary here, and I'm going to use up this space over here to the right. So 1 minus cosine is, my cosine in this case is going to be negative 3 divided by the square root of 10, all divided by the sine of theta, which in this case is going to be negative 1 divided by the square root of 10. Now, what I'm about to do is not going to be what everyone does to solve this problem. I'm just going to show you what I feel most students end up doing because they want to reconcile, first of all, the square roots and the denominators. So I'll do that by multiplying this by a 1, which is a fancy square root of 10 divided by square root of 10, which means my numerator of this fraction here, this complex fraction, is going to be 1 plus, because the two negatives make a positive, 3 square roots of 10 divided by 10. Now down here, I'm going to multiply this also by square root of 10 over square root of 10, and that means I'm going to have negative square roots of 10 divided by 10. Now I'm going to then get these two, this binomial together, because this 1 can be written as 10 over 10 by multiplying the top and bottom by 10. So now I have 10 plus 3 square roots of 10 divided by 10, all divided by negative square root of 10 divided by 10. So here I have my big complex fraction, and I'm going to then skip, flip, and multiply. I'm going to take my numerator, which is 10 plus 3 square roots of 10 divided by 10, and skip, flip, and multiply this one. So the denominator is going to be in the denominator is going to be in the numerator, and here's my denominator here. So these 10s simplify to 1. I think you would say cancel, but they simplify to 1. And now what I have is 10 plus 3 square roots of 10 divided by negative square root of 10. Well, I can't have a square root in the denominator, so I'm going to multiply this by negative square roots of 10 over negative square roots of 10. Now I could have just multiplied by square root of 10, but why not get rid of the negative at the same time? So our denominator could be a beautiful integer, and in fact a whole number, because we won't have a negative down there. So I'm going to then do some quick multiplication. Negative square root of 10 times 10 is negative 10 square root of 10. The negative square root of 10 times 3 square root of 10 is going to be negative 3 square root of 100, or just 3 times 10, which is 30. I will be changing the order of this numerator because I like to put my radicals after my rationals. Because it goes rational, irrational, imaginary, and I'll keep it in that order. And the whole denominator will be 10, because negative times negative is positive, and 10 square root of 10 times square root of 10 is a square root of 100, which is just 10. Now, I can divide everything by 10, because this negative square root of 10, this negative 10 square root of 10 divided by 10 is just negative square root of 10, and the negative 30 divided by 10, which is equal to negative 3. Or, using the symmetric property, negative 3 minus the square root of 10. Now, this is something I could have done over here. This dividing by 10 is because I could have split this into this binomial like so, and notice that each part was divisible by 10. This is a common mistake sometimes when you have one number that isn't divisible by both of them. You couldn't actually do this step, but since both were divisible by 10, I could totally do this. Now, I want you to look at all 6 of these answers for this problem. This cotangent theta, oops, move the screen again. This cotangent theta equals 3 cosine theta is less than 0. Now I want to show you how to find this answer on a calculator, but first we'll need all of our answers. Okay, so what we're going to do here is we're going to check our answers. Now it's possible that your book will have many of the answers in the back so you can check your work, or if you purchase a solution manual that would be the case. But sometimes the book does not put in all of the answers, like let's say for example the half angle and double angle formulas for tangent. So how are you going to check to make sure that you didn't do the entire problem and just mess up at the end? Well, luckily our graphing calculators can totally help, but we need to do a little bit of work first. We need to figure out what this angle is. Now to find this angle we can use an inverse function, because an inverse function can find us a location if given a proportion. So if I take this inverse tangent of negative 1/3, I will get an angle of approximately, and I can show you this on the calculator, approximately 18 degrees, but we're going to put it as 18.435. And the reason why we want some decimals is because since these are all going to be typed into the calculator, the more decimals we use, the more accurate the answer is going to be. Now, it is true that this angle here in the third quadrant is 18.435 degrees. But what you have to realize is that this angle is part of a bigger angle that's made of this rotation starting from 0 degrees all the way to this mark here on your triangle. So therefore, you should do a little bit of thinking and say, okay, since this goes from here to here, this is actually 180 degrees added onto my 18.435 degrees. So this is really 198.435 degrees approximately. It's not exactly 200, it's not exactly 198, this is a decimal approximation of how big this angle is from the 0 all the way to that tipping point right here. So let me show you how we can do this on the calculator. So on the calculator, the first thing you would need to do is you need to click on the mode key and make sure that you are in degree mode. Somewhere on the first page of your menu, you're going to have to select degree, and this will give you what you need. So now that we're in degree mode, I can show you that I can type the inverse tangent, which is clicking second tangent, and then going negative 1 divided by negative 3. I now see that I don't have my negative right there. I will change that in just a moment. And this will give me the answer of the 18 degrees. And I add my 198 to that, or 180 to that. and that will obviously give me the 198.43, and I round it to the third decimal there, 5. So because my brain won't let me turn this off, I'm going to put that negative in there, which obviously 2 negatives make a positive, but I still want to have that there just so people know where that came from. And now that I can't bear looking at it anymore, there we go. That's fine too. So let's bring our calculator back and see how we're doing. Okay, so now that I have my calculator, oops, okay, I got that fixed. Now that I have my calculator back, I'm going to look at the tangent of 2 theta. Now, first of all, 3/5 is 0.6. So if I type in the sine of my angle, which is 198.435, and double it, now what that gives me is something that will be close to that 0.6. So now I verified that that's true. Now 4/5 is exactly 0.8. And if I go second enter, I can get my answer back and change that sine to cosine and check my answer there, which again is very close to 0.8. It's not exactly right because, of course, we're using an angle approximation. If we used all 10 decimals here, we would actually get something that would be exact to that answer because of rounding. Now 3/4 is 0.75. If I hit second enter and I change this to tangent instead of cosine, what you'll see is that is 0.75. Now it's a little bit tougher to check the half angle formula. So what I want to do first is actually type in my answer. So I'm going to start from the inside of my square root. I'm going to go 10 plus 3 square roots of 10. And then I'm going to divide by 5. And then I'm going to take the square root of the answer. So I'm going to hit second square root, second negative. That pulls this entire decimal into that radical there. And then multiply it by 0.5. All right, so I'm going to be comparing the sine of angle divided by 2 to this 0.987. So if I hit second enter a bunch of times, you'll see that it goes to previous parts of the problem. And the reason why I'm doing this is because earlier in the problem, I did the sine of this angle. So I'm going to change that tangent to sine and change this to a division problem. And that should give me something close to 0.987, which it does. It's very close, in fact. So let's go check out our cosine angle divided, or cosine theta divided by 2. So again, I'm going to walk through my problem of taking my 10 plus, or excuse me, not in this case, 10 minus 3 divided by square root of 10. That's the inside of that numerator here. Oops. And then I'm going to divide by 5. And then I'm going to take the square root of the answer, so hit second negative to pull that 10-digit decimal into the radical. And then I'm going to multiply this by negative 1/2, or negative 0.5, which is equivalent. And now what I'm hoping to see is when I actually check my cosine of theta divided by 2, it's close to this answer. So let's go hit second enter a bunch of times to get back to my cosine, or actually it looks like sine in this problem. So I change that to cosine, and there you go, negative 160, negative 0.16018. Hey, it's a match. So it looks like I'm on the right track, so let us now do the tangent of theta divided by 2. Now I'm going to actually type that in first here. I'm going to change that cosine to a tangent, and then hit enter. Okay, so I've got this negative 0.616. So let's see if that works out. Negative 3 minus the square root of 10. Do I get negative 0.616? I do. So now I've checked all my answers. And it's really important to check your answers because if you're doing a take-home homework assignment or an open book or open note quiz or test, you may want to make sure that you're getting the right answers as you do the problems. Well, thanks for sticking around. I really appreciate you checking your work and watching these videos.